Today, we will be covering partial fractions, and I'll be going through very quickly how we go about splitting fractions into partial fractions. Okay, so first of all, when do we use partial fractions? Well, we use it when we want to split a single fraction like this one over here into two separate fractions with the denominators as each factor. Okay, so when we're splitting a big single fraction into two simpler, smaller fractions. So there are two ways of actually doing this. We can either use substitution or we can use equating coefficients, and I'm going to show you how to use both methods. So first of all, we're going to start off with, let's go substitution first, okay? Before we even go about doing these methods, we first need to combine these two single fractions, this a and b, into one whole fraction. Hopefully we know how to do that. So we're just trying to make the common denominator. That means we're going to have a, and then we'll have x plus 4 plus b times x plus 1. Okay, and that's all going to be over the common denominator x plus 1 times x plus 4. Okay, so if we make them into a single fraction like such. What you should notice now is our original fraction and this fraction we just made, the denominators are now the same. So all we need to look at now is the numerators. Okay, so the numerators will have 2x plus 11 should be equal to is ax plus 4 plus bx plus 1. Our next goal is just to find what our a and b values are. These a and b values will be constants, so we just have to find them. And as we said before, there's two ways of doing it. There's either the way of substitution. So number one, we can use substitution. Okay, or number two, we're going to equate coefficients. So I'm going to use substitution first just to show how this method works. In this method, what we do is try and make one of these values equal to 0. So for example, if I want to get rid of this a term, then if we let x equal to negative 4, this a, if we have to plug negative 4 into every term where there's an x, so we have 2 times negative 4 plus 11 would be equal to a times, in brackets, negative 4 plus 4 plus b times x, negative 4 plus 1. Okay. What we see now is this a term, minus 4 plus 4 becomes 0. So it's a times 0, which means it's 0, so that a term disappears. And what we're left with is just this b term. And if we were to go about completing this, so we have minus 8 plus 3, so 11, so that's 3. That's equal to minus 4 plus 1 is minus 3, so it's minus 3b. Okay, sorry, this is a 3. And therefore b will be equal to negative 1. Okay, so what we went about doing is try and get rid of one of these two terms by making it equal to 0. So we found the b value. Now we have to find this a value. And once again, like before, we're trying to get rid of this b term here. So what we can do is set a, we'll let x equal to, in this case, it will have to be minus 1. That way, minus 1 plus 1 would be equal to 0, and the b value will disappear. So if we let x equal to minus 1 and plugging it into the formula, we'll have 2 times minus 1 plus 11, and that will be equal to a, and then in brackets we'll have minus 1 plus 4 plus, I'll write that b term out as well, so b times minus 1 plus 1. As you can see again, this b times minus 1 plus 1, that goes to 0, so that will disappear, and what we're left with is minus 2 plus 11, that is going to be 9, equals to minus 1 plus 4 is 3a. And therefore, a will be equal to 3. Okay, so this original fraction, large fraction, we can split up into saying that it's going to be equal to 3 over x plus 1 minus 1 over x plus 4. And that is essentially how we go about splitting up a large fraction into two smaller linear fractions. So as we said before, there's two ways of doing it. We can use substitution as like this, or we could equate coefficients. So I'm going to show you how to equate the coefficients. So this is exactly the same question as before, okay? So once again, we just have to combine or make it into one single fraction again. So we have a x plus 4 plus b x plus 1. As I said before, the method is exactly the same until we combine the fractions, like such. Once again, showing that the numerators are the same because the denominators are already the same. So ax plus 4 plus b times x plus 1. Okay, so up to this point, it's the same as using substitution, but now it's slightly different, okay? So in this second method, we're going to do is we are going to equate coefficients together, okay? Coefficients. Okay, so what does this mean? Well, it means that here, in this 2x plus 11, we have an x term and we have just a number, constant term, okay? So that means on the right-hand side as well, we'll have some x terms and we'll also have some constant value terms. So let's expand the brackets on the right-hand side, meaning that we get ax plus 4a plus bx plus b. Okay? So every x value, the left-hand side x's have to equal to the right-hand side x's. So therefore, we've only got a 2x here, so we write equating the x coefficients, it means that we have 2x is equal to ax plus bx. Same thing for the 11. 11 is a constant value, so equating the constants together, we have 11 is equal to all the constants or the integers on the right-hand side, which is equal to this 4a here plus this b. As you can see now, we have two equations, and so we can use simultaneous equations. From this first one, I'm just going to get rid of the x's and write it below, so that means we're going to have 2 is equal to a plus b. Okay, and therefore we can now use simultaneous equations. So if I take away the top one from the bottom one, I'll have 9 on the 9 is equal to 4a minus a is 3a, and b minus b is just 0, so it's 9 is equal to 3a, and therefore a is equal to 3. Okay, and now we just have to reinsert or put it back into any of these equations. So I'm going to put it back into the second one here. So we have 2, not negative 2, is equal to a plus b. A we found out to be 3 already, so 2 is equal to 3 plus b, and therefore b will be equal to negative 1. And as you can see, we get the same values as before, as the substitution one. So it's all a matter of preference. Which one are you more comfortable in using, and which one is easier for you? It's different for each student. So let's do another quick example, okay? So this now we have 3 terms on the denominator, okay? But it's still the same method, exactly the same method. So what we're going to have to do is going to split this large fraction, single fraction, into its partial fractions. So we're going to have x plus 1 is the first one, so it's going to be a over x plus 1 plus b over x plus 2 plus c over x minus 5. One thing to note, it does not matter which one your a, b, c are, okay? Because you can put a, b, c above whatever fraction you want, okay? It does not matter because you should get the same value all the time. Our next step is now to combine this back into a single fraction. So we're going to have a times x plus 2, x minus 5, plus b times x plus 1, x minus 5, plus c times x plus 1, sorry, I'm going to write it underneath, x plus 2, like such, okay? And that is all over the same denominator as this whole single fraction here. So we can just equate this numerator equals to the other numerator. So that's equal to minus 5x squared minus 19x minus 32. So I'm probably going to use the substitution method because it's slightly faster than the coefficient ones. So remember, from the substitution method we learned, we're trying to get rid of one of these functions. Or in this case, we're trying to get rid of 2 of them. Okay. So what we can say is, let's let x equal to, let's try and get rid of this a term. So to make a 0, one of these 2 terms has to be equal to 0. So if x plus 2 is equal to 0, then x will have to be negative 2. Because negative 2 plus 2, that's 0, so therefore a will be 0. If x is negative 2, I plug it into the left-hand side, so minus 5 times negative 2 squared minus 19 times negative 2, so minus 32, and that is equal to, well, this a term will now disappear, because as we said before, x minus 2 plus 2 is 0, so a will disappear. This b term will have b times negative 2 plus 1 times negative 2 minus 5 plus, as you see in the c term, this also has an x plus 2 in brackets. So if we were to place this x as negative 2 into it, this c term will disappear as well. So in fact, what we just have is just this b term here. So quickly working these out was 4 minus 20 plus 38 minus 32. Okay, that is equal to b times minus 1. So this is minus 2 minus 7. Okay. So what do we have here? So we have 6 minus 14 is equal to 7b, and therefore b is negative 2. Right, what's another substitution we can use? Well, let's let x equal to, in this case, we want to keep the a term, so let's try and get rid of this b term here. So as you can see with this x plus 1, if we let x equal to negative 1, then that b term should hopefully disappear. Once again, plugging this back in, so we have minus 5 times minus 1 squared minus 19 times minus 1 minus 32 should be equal to this a term here, so a times minus 1 plus 2 times minus 1 minus 5. This b term, as we said before, will disappear, and so will this c term, because this c term also has this x plus 1 here. Okay, so we just have this a term here. Okay, working this out again, so minus 5 plus 19 minus 32, and that's going to be equal to minus 1 plus 2 is a times 1 times negative 6, like such. So we have 14, what do we have here? Minus 18 here, and that's equal to minus 6a. Right, therefore a would be equal to 3. So we found the a term and the b terms, so we need to find the last c term. So you should know by now, if you look, we got rid of this a term and the b term by letting it to x is minus 2 and x is minus 1. So the only other factor we have is this x is equal to minus 5. So what we can say is let x equal to 5, like such. Replacing this into our formula, we have minus 5 times 5 squared minus 19 times 5 minus 32, and that is equal to all the terms on the right hand side. You should notice as a term will disappear because we have a 5 here, so will this b term, so we'll just be left with the c term. So it's going to be equal to c times 5 plus 1 times 5 plus 2. So we have minus 125 minus 95 minus 32, and that's equal to c times, 6 times 7. And if you work this out, c will come out to be negative 6. So we found the a term here, and we found a b, and we found a c. So this initial large single fraction we can split up into partial fractions, which is going to be equal to 3 over x plus 1. Our b term is negative 2, so it's minus 2 over x plus 2. And our c is minus 6 over x minus 5. So this is how you go about doing partial fractions. You can use either method, just stick with the one that's most comfortable for you.